Okay, here's the last two learning targets we need for day 2 here. I can use the horizontal line test to determine when our weather functions are one-to-one. So a new phrase we need to go over and cover today. And then I'll show you how to find inverse functions algebraically, not analytically. Okay. Okay, to help with this definition of one-to-one functions, I want you to write this down in place of example 5. We're not going to do example 5. Let's use this space. So this reads, closer look at inverses in one-to-one functions. Write that down. Closer look at inverses in one-to-one functions. Okay, now we're going to use, I'm just going to use y equals x squared as our demo. So using y equals x squared, let's plot just some basic points from this parent function. Okay, 0, 0's on that quadratic. When we plug in 2, obviously we get 4, and we plug in -2, we get 4. So if we plot those in the coordinate plane, we get this parent function parabola. Okay, so let's take a look at the definition of a one-to-one function. A one-to-one function is a specific type of a regular function. Okay, we'll get to the horizontal line test here in just a second. It's a little out of order if you ask me. Okay, a function is considered to be one-to-one when each value of the dependent variable, remember that's y, so each value of y corresponds to exactly one value of the independent variable x. Okay, so remember our original definition of functions from the past. For something to be a function, each x had to be assigned to one y value. But now they flip-flop this for one-to-one. Each y value can only be assigned to one x value. Okay, so basically, for it to be a one-to-one function, each x has to have one y and each y has to have one x. So basically, you can have no x and y values repeated. So let's just kind of add that in here. So you got to make sure there are no x or y repeated values. No x or y repeated values. Okay, so let me demonstrate this definition with this y equals x squared. Each x does have one y value. This does pass the vertical line test, right? When x is 2, it's y value of 4. We only see one y value. When x is 1, one y value, and so on. However, we do have repeated y values. Okay, when x is 2 and -2, we have repeated y values of 4. And that's not the only example. It happens at 3 and 3.5. I have a bunch of repeated y values. So this is not considered a one-to-one function. Okay, so let's add that here. Y values are repeated, not for all of them, but for some of them, right? When it's 0 and above. So what that means is this is not a one-to-one function. Okay. Which is why the horizontal line test works for the one-to-one test. Remember, the vertical line is just for a regular function. If you want to check to see if it's a one-to-one function, what we can do is if we draw a horizontal line anywhere, it confirms that I have two y values at 4, where I drew it. And I have two y values at 3, or wherever I want to draw that line. Okay, so if it intersects at more than one spot, we say it's not one-to-one. We need to see something like this. Maybe a graph that's y equals x cubed, right? It looks like this. This is a one-to-one function. It passes the vertical line test and it passes the horizontal line test. Intersects at one spot. Okay, so that's what you're looking for it to be one-to-one. Okay, now there's another characteristic of one-to-one functions. A function has an inverse function only if it's 1 to 1. Let me demonstrate that with our demo up here. I want you to just draw a divided line, and let me show you what happens if we take the inverse of this. So, inverse of y equals x squared will have these ordered pairs, right? We learned this yesterday. Take the ordered pairs and flip it around. It's going to have 4, -2. It's going to have 0, 0, and 4, 2. Okay, I'm going to make this graph a little smaller so I can fit some notes over here. Pause for a moment, get you a chance to write that down. Okay, so this graph does not pass the vertical line test. So this does not pass VLT. Meaning what? The inverse is not a function. Okay, so I'm doing this just to give you visual aid and emphasize this sentence. A function only has an inverse function if it's 1 to 1. This was not a 1 to 1 function, so that's why the inverse was not a function. Okay, so just make sure we're perfectly clear here. A function must be 1 to 1 to have an inverse function. Must be 1 to 1. Okay, so we actually will use quadratics on this sometimes. They'll just restrict the domain. They'll just say that let's use half the parabola. And if we use half the parabola, it is 1 to 1. And then it will have an inverse. Okay. Okay, so now we're ready for example 6 and 7. Question says, does the function have an inverse? So basically what we want to find out, is it 1 to 1? Because if it's 1 to 1, then we know it has an inverse function. So that's the key step here. So are there any x or y repeated values here? Well, I do right here, -2, 5, and 2, 5. You could plot these points. If I plotted these points and quickly did them, I'm just going to do this really quick, but -2, 5, and 2, 5, and 0, 1, basically we have a parabola. It's going to kind of look like this. And it doesn't pass the horizontal line test, but you don't necessarily have to do that. If you can just remember, if I have repeated y values, not going to work. So this is not a 1 to 1 function. That's not what they're asking for. I'm trying to leading you through these steps. So if it's not a 1 to 1 function, it means it doesn't have an inverse function. So does the function have an inverse? No. So therefore, so no inverse function. Or in your own words, something like that. Okay, take a look at 7. See if you think you can figure that out. Okay, the directions do say justify my answers. That's why I'm justifying it. This is a 1 to 1 function, no repeated x or y values, so we're good. It does have an inverse function. Okay. All right, and they may present that in a couple different ways. They may give us the table values like we just talked about, and you could just look at it or plot them if you want to, or they may start with a graph, and you just got to use that simple horizontal line test. Pass the vertical line test. This is a function, but it might not have an inverse function if it's not 1 to 1. So horizontal lines can be drawn, right? Okay, so you could say does not pass HLT. So no inverse function. Number 9, this does, right? This is going to continue to increase ever so slightly. Even though it looks like it's going to get horizontal, it's not. This will pass the horizontal line test. So passes, sorry, that was sloppy. Passes HLT. So it is 1-to-1, meaning it has an inverse function. Okay, last type of example we're going to go over, finding an inverse function. So here's the success criteria for that. Use the HLT to decide if it even has an inverse function, because if it doesn't, we're not going to find it. We'll stop. Okay, 2, 3, and 4 are involving some algebra. Step 5 will be optional. It's a way to check your answer. So step 5 is optional. It's a way to check your answer. Okay, so here we go. I'm going to take you right through this one step at a time. Step 1, use the horizontal line test to decide whether f has an inverse function. If you have a graphing calculator handy, you can plug this in yourself. If you don't, just watch me. So they didn't provide a graph, so we'll just create our own. Remember, whenever you have a fraction like this, make sure you close your numerator. So I want to start with parentheses in order to get this graph correct. 2x plus 6, all of that is divided by 5. And I'm just going to hit zoom 6. Take a look at that. It's just a linear equation. Remember, this is the form y equals mx plus b, right? 2/5 x plus 6/5 if I divide them by 5. So we should have no problem with that. Horizontal line is only going to intersect one spot. Okay, so you don't need to actually copy down the graph if you don't want to. You just got to make sure you checked. So passes HLT. So that means it has an inverse function. And we can move on to step 2. Step 2, in the equation for f of x, replace f of x with y. Right, those are always interchangeable. That's no problem. Simple step. I'm just going to find where f of x is. I'm going to replace this with y. So y equals 2x plus 6 over 5. All right. And 3 fits right along with the beginning examples we did yesterday. Interchange the roles of x and y. Switch the domain and ranges, and then we got to solve for y. So this y is going to go over here in the x spot, and this x is going to go over here in the y spot. So x equals 2y plus 6 over 5. Okay, now the algebra starts. We're going to see a lot of different types of these problems, so I can't always give you a set way to solve it. You just got to use those algebra 2 skills. It'd be really easy if I just said 2y plus 6. So your first step is to figure out how to get rid of the divided by 5. So it's multiply by 5. Right? Multiply by 5 to both sides, balance your equation, multiply this side by 5. I'm going to work over here now. So on the left, I have 5x. On the right, we have 2y plus 6. Okay? Remember what we're doing. We're just continuing to solve for y. So I get y by itself by subtracting 6. And dividing by 2. So we have, usually we like y on the left when we write these functions. So y equals, now you could divide these by 2 or you could write it like that in fraction form. I don't really care. And you check in the back, they may mix it up too. They might have this form, they might have that form. Doesn't matter, they're equal. Okay, all right, divide them by 2. All right, so we solve for y. That's the end of step 3. Step 3 is always going to be the longest step. 4 just says replace y with the inverse notation in your new equation. So here's step 4. Okay. All right, I'll show you option 5.